Hi everyone, today we'll be talking about how to design a wall footing in ClearCalcs. So we'll go to the add a new calculation, and the wall footing template is located here under foundations and retaining walls. Once we open up that template, we'll see that for this calculator, we reference ACI 31814, so all designs are done to that standard. And here we can see the assumptions we make for this calculator. So we assume that wall is centered on the footing, and we don't do any checks for the wall to footing connection itself. The lateral loads are only used to check sliding, and we will do a check for development length. And the other thing of note is that if there is insufficient development length, the calculator will automatically check if a plain concrete design will work, and the sheet values will update to a plain concrete design. So let's get into the actual template itself. And in this section, we can see footing properties. So we can enter in the actual dimensions of the footing thickness, as well as the wall width and the concrete strength, and any type of concrete classification differences. Then in the next section, we can enter our soil properties. So the foundation is quite dependent on the soil bearing pressure, as well as the weight of the soil and the sliding coefficient, which will impact whether or not the entire footing could shift under the loads. And then here we put in bottom reinforcement. So in this case, bottom reinforcement refers to transverse reinforcement, which in this diagram is the horizontal line noted here. And by default, we include it. We can toggle this on and off. And toggling this off will remove that consideration. So by default, we consider this, and we can set our reinforcement size and spacing here. And here we can set whether reinforcements are straight or they're hooked. It is of note that if there's not enough development length for the hook, our calculator will not pass, and it will tell you that there is not enough length for the placement of the hook. And then from there, these are the calculations that come from the input of the bottom reinforcement. And then next is the longitudinal reinforcement, which are the reinforcement that goes in and out of the page. So we can set our number of bars and bar size. So this is number 5 bars as shown in the diagram here. And then we can also choose to include top reinforcement, which is good if you have any hogging moment, or if there's for any non-positive bending moment, or to control cracking. So by default, that's off, because usually the bending diagram for footing is all positive, and there's no need for top reinforcement, and that is completely dependent on the design and case. And then here we can input applied loads. So we can apply vertical loads, lateral shear load, or any moment loads. And then it'll consider the self-weight of the concrete footing itself, as well as the soil on top. So that would be these two portions of soil here. In the design criteria, we list that we use the IBC 2018, and you can manually set or override the minimum overturning and sliding factor of safety. And changing this will change the utilization for sliding and overturning. And then here we calculate the total loads using ASD and LRFD combinations using ASCE 716. And we can see all the loads listed here. And then for calculations, we will calculate flexural analysis and one-way shear. And all of these the results of all of these calculations are noted in the summary box here, as well as the utilization. So in our case, the worst case load combination is 1310 PSF, and the allowable gross bearing stress is 1500 PSF. And we'll list the utilizations all here. And finally, we'll also list the overall stability of the footing, and we'll note whether the footing is in total compression or if it's potentially unstable, if there's a line of action elsewhere, or if it's, and we'll flag if it's stable or unstable. And so, and that's it for our footing design template.